Hello everyone, my name is Hideo, and I hope you're doing well in creating more for January than I am, because I have stopped doing anything after this prompt that I'm going to talk about today. So in this video, I'll be going through how I created the artwork for Destroy a Square prompt. I decided to revisit recursions for rectangles division, but with a little bit more craziness. I did a video on this with animation nodes and Blender, and I also have a full course on Skillshare dealing with recursions in general. This is going to follow a similar code structure to the 3D one, but we'll have to do some things differently. First, let's demo the idea real quick. Starting with a four-sided polygon, what we want to do is pass that into our class, divide it into two pieces, and return those as our new input, resulting in two four-sided polygons. If the one we started with is A, B, C, D, and the cut is a line E, F, then our new polygons are going to be A, E, F, D, and E, B, C, F. That's easily the concept, and hopefully it makes more sense when we translate it into code. Let's create the class. I'm going to call it poly for polygon, and it'll always be a four-sided polygon for this because we'll specify the input points for that. Those will be A, B, C, and D p vectors, and the constructor will have the same with underscores for the names to differentiate them from the above variables. Then assign each parameter to its equivalent variable. So whatever we pass in as argument, it'll be assigned to these. For displaying the polygons, I'll use vertices. The first will be point A, the second is B, the third is C, and the fourth is D. Note here that the order matters when you input your new polygons. We're going top left, top right, and bottom left, and finally we use close to connect the last point to the first. If we display this right now, we should have a polygon. We can do that by creating an array list of polys and also initialize 4 p vectors, A, B, C, and D, just for cleanliness. And to make code lines shorter, I'll also add a margin of 100 for a bit of negative space around the artwork so we can see it better. And now let's initialize the p vectors. The first one will be at margin. The second will be width minus margin and margin. So now we're moving to the right. Then we'll go down to width minus margin and height minus margin. And finally, we're at margin and height minus margin. This way we have a polygon with margins around it. Now let's add it to the polys array list and use the 4 p vectors we just created. And if we display all the polys in the array list, we'll get the one we just made. However, that's not what we want to do, so going back to the class, let's create the points for the next generation. Because we have points A, B, C, and D in the new polygons as well, we'll have to copy those over to the next generation. And by the way, I followed the Nature of Code book for some of this when I first created recursive functions, so I'll link to that in the description. To copy the original positions of the points, we can simply create a method that copies each and returns new ones at the same positions. We'll call the first one point A, and we'll do the same for point B, point C, and point D. For point E, however, since it's a point that goes between point A and B, we'll create a new p vector named E, and that will interpolate between the 2 points at a random position from 25% of the input line to 75% of the same line. I made it random, but if you want it to be exactly in the center every time, then 50% it is. But we're going for crazy, so random it is. Point F will be the same, but the 2 points that we're interpolating between are C and D. That's a line parallel to line AB. We'll continue with one cut for now, but we'll return later to create a horizontal cut as well. Now it's time to create the recursive function. So in the main tab, let's create a function called drawPolys with an integer parameter for resolution. That's going to be the number of generations or divisions. Because recursions are technically infinite loop, we'll have to check if res is greater than 1 and create the next generation in there. Then decrease the res variable after the if statement, kind of like a while loop. And if we return to our demo, we know that we need an input, then adjust it or cut it, and finally return the new input in place of the old one. So we'll create a temporary array list inside of our recursive function. Then inside of our if statement, we'll get everything from the main array list using a for in loop and start dissecting our polygons. For now, we just have 1 in the array list. So let's start cutting it. Let's call the first 4 methods from our class to copy the points from the current polygon, and we'll store them in local p vectors so we can later use them to create our new generation. Then we can call our other 2 methods and also store them in p vectors for later use. We can start adding polygons to our temp array list now. And as I mentioned earlier, the new polygons are going to be called AEFD and EBCF. Again, the order is very important here. Moving right, down, left, and end shape in the display method will manage the upward movement and closing the shape. Final thing, well, not the final, but for this to work, we'll have to replace all of what's currently in the polys array list with what's in the temp array list. In processing, you can just assign temp to polys. And of course, for the recursive function to loop, we'll call it inside of itself after everything. And now we can call the drawPolys function inside of draw before the loop with the display method, passing in a number for your desired resolution. Running this will result in many vertical cuts, so it's time to go back and add 2 more points for horizontal divisions. So going back to the class, let's add 2 more methods called point G and point H, and we can copy what we have already for point E or F, but change the lines we need to cut. For point G, it'll be an interpolation from point B to C, and for point H, it'll be cutting the line AD. Then in the recursive function drawPolys, we'll add 2 more local p vectors, G and H, calling the methods we just created. And what we need to do now is generate 2 scenarios, where one is a vertical cut, and that's what we have now, and another that is a horizontal cut. For that, we'll need a float called RND that produces a random value from 0 to 1. That's just what I chose for the variable name, but feel free to choose whatever you want. And then I'll check if RND or random is less than 50%, then it's the vertical cut, else we'll have 2 new polys added to the temp array list with points A, B, G, H, and H, G, C, D. Let's run this and check that we're getting some vertical and some horizontal divisions. What I did as well is add another probability for a polygon that stays the same with no slices. That way we can get bigger chunks. That will simply be A, B, C, and D, so the original points of the input polygon. Of course, we need to adjust the numbers for the conditions, so maybe make one 25%, the other one 50%, and the last one, again, 25%. That already produces a pretty hectic looking square, but I wanted to add an offset for each of the points. At first, I wanted a bit of room between the polygons, so offsetting in a way that creates margins, but I thought it would be more fitting for the prompt to create just random offset for a crazy look. That way the square is actually destroyed, not sliced. For that, I'll define a constant inside of the class called offset with a value of 10. That's what I did for my sketch anyway, but you can choose to make it smaller or crazier. Then I'll define 4 floats, A off for A offset, and then B off, C off, and D off. And I'll initialize them with random values from negative offset to offset. I'll then simply add them to each of the x and y values for the corresponding points in the display method. So A offset will be added to point A, or the vertex with point A, and then the same for the rest. Also, we're at a point where we can add color. I chose randomness from an array of colors. You can also generate colors based on the previous generation or based on position or size. Now, if we run this with a resolution of 10, let's say, we should get a destroyed square. And that's it for this prompt. I don't know how many of the prompts I'll end up making, but I'll surely create a video tutorial for each one that deserves it. For now, that's all I have. And I wish you good health and a wonderful time creating, and I'll talk to you soon.